Hey guys, Mr. Backerberg here. In this video, we're going to be looking at reference angles. So as we're talking about reference angles, what's happening in here is we're going to be dealing with our angles plotted out in standard position. So starting along the positive x-axis and then rotating around. And let's say this is our angle theta, and maybe theta is 140 degrees. What a reference angle is the small acute angle formed between the terminal side, the ending side of your angle, and the nearest x-axis, whether that be on the positive side or the negative side. So this acute angle over here is our reference angle, and I'm going to call that theta prime. Now we can actually figure out how big this small acute angle is. We've talked about this quadrantal angle over here as being 180 degrees, and we just said that our angle theta was 140 degrees. So we're trying to find kind of the distance between where this terminal side is and this 180 degree angle. Well, we know that our theta is 140, so in order to get from 140 degrees over to 180 degrees, then my theta prime angle in here would need to be a 40 degree angle. Now something similar could happen if we had an angle drawn out that takes us into the third quadrant. So again, starting along the positive x-axis and rotating around. And let's say that this angle theta in here was 218 degrees. Now we said that our reference angle was formed between the terminal side and the nearest x-axis. So here's the terminal side of our angle. The nearest x-axis is still this negative x-axis. So this angle right here is our reference angle theta prime. Now we know this quadrantal angle over here is still 180 degrees, but this time our angle took us past 180 degrees. So we're trying to figure out how much past 180 we went. So if I take 218 and subtract off the 180, then that should leave me with a 38 degree reference angle. Now we could also have an angle take us into the fourth quadrant and find a reference angle. So we're going to start along the positive x-axis again, and we're going to rotate around, but this time down into the fourth quadrant. And let's say that this is our theta, and let's call it 300 degrees. Now the reference angle is between the terminal side and the nearest x-axis. So this angle right here is going to be my reference angle theta prime this time. Now this quadrantal angle, if we think about making one full circle, one full trip all the way around, would be 360 degrees. So if we know that our theta is a 300 degree angle, then in order to complete this circle to get all the way around to that 360 degrees, then this theta prime would need to be a 60 degree angle. Now we also know that there are angles that just land us in the first quadrant, and we don't typically talk about reference angles in the first quadrant because if we had, say, this is our theta and it's a 50 degree angle, the nearest x-axis is that positive x-axis, so your theta and your theta prime end up being the exact same angle in here. So reference angles in the first quadrant aren't super important, but as we start moving into the second, third, and fourth quadrant, we'll need to know how to find those reference angles. Now there may be some times where we need to deal with reference angles as we're working with negative angles. So if we're dealing with an angle in standard position, so starting along that positive x-axis, remember positive angles rotate counterclockwise around, but if we go clockwise, that's a negative angle. So let's say my angle goes this way into the third quadrant, so that's going to be my theta, and let's say that's a negative 150 degree angle. The reference angle is still between the terminal side and the nearest x-axis. So I would be looking at this as my theta prime angle over here on the left-hand side. Now, as we're working with quadrantal angles, half of a rotation is 180 degrees, but since we're traveling in the negative direction, this quadrantal angle over here on the left-hand side would be negative 180 degrees. So as I'm looking at finding my theta prime, I'm still looking at the distance between these, but we always want our reference angles to be positive angles. Technically, as we're moving from that negative 150 degree theta angle over to this negative 180 degree angle, that would technically be a negative 30 degree angle. But like I just said, we always want our reference angles to be positive angles. So we would just call that a 30 degree reference angle. Now I'm going to deal with the same theta, but I'm going to look at finding my theta prime in just a little bit of a different way. So I'm going to draw out a different picture over here, and I'm still going to deal with that negative 150 degree angle taking me into that third quadrant. Now, one thing we visited before was coterminal angles. And remember, coterminal angles are angles that start in the same position and end in the same position, but they're different sized angles. I could actually take this negative 150 degree angle and turn it into a positive angle by adding a 360 degree rotation. So if I add 360 degrees to this, I'm going to end up getting 210. So that's going to be the positive angle, 210 degrees. So we'd still start at that positive x-axis, but we'd rotate counterclockwise around. So this would be my 210 degree angle. So now I can think about this angle on the left-hand side as just being positive 180 degrees. And as we're looking at finding the reference angle over here, the distance between that 180 degree angle and our 210 degree angle is 30 degrees. So we're getting the same answer either way, but we do have to remember that we always want our reference angle to be a positive angle, even if our initial theta angle is negative. That's going to be it for this video. Thanks for watching.